Hey, good morning. It is 25 past 1, back in the office again, and I'm using my coffee break to make a video basically filling you in with where I am at the project right now. Like I said I would in my last video. Now, that last video, granted, went on for a little bit too long, but there was a reason behind that. So, if you haven't seen it, I'll link it up here. And what it was the process. The process of building a guitar from a box of parts from a Chinese eBay seller all the way through, like chronicle the entire process all the way through to a working, functioning, pretty decent sounding guitar. Like, the fact that it works at all is a miracle. The fact that it sounds as good as it does is unbelievable, considering I have no idea what I'm doing. And it's because I had no idea what I was doing that video was so long. So what I thought I would, do in that was, rather than do what I'm doing now and just explain to you the process of how it worked, weeks before when I was building it, I was making a load of little WhatsApp video messages and sending them to my mates. So what I did was I just took that footage, chopped it all up, butted it together, and that was me chronicling from beginning to end. So I'm going to do the same here, but I'm going to take this moment in this coffee break right now to very quickly run you through two things. Firstly, the concept, and secondly, the process. So rather than make the four party tricks that this guitar does into one video, what I'll do is take each one of them and separate them out into their own video so it doesn't go on forever. The first one I want to do today is the blood. So let's get into it. Now, again, recapping, when I build a project, and it's not just like this project, it's every project I do, whether it be one of the Raspberry Pi builds, even for like the PlayStation build, or even the controller repaints, I need an anchor, I need a waypoint, I need something to be heading towards. I can't just start building something and then figure it out as I go. I need a specific point. And the reason I do that is because I'm not, like, I used to sketch and I used to concept stuff and figure it out on paper. But now what I do is I sort of, like, the best way to describe it is like build it in my head, or like really sort of consider everything in the process. Now, there'll always be roadblocks when I actually end up building it, but for the most part, I kind of have it in my head exactly what I want. And then it's just a case of aiming towards it. It makes things super simple. So the concept with this project was something that I really wanted to do. So I've always wanted to build a guitar. That's been a thing for years. But I needed a theme. I needed a concept. I needed a waypoint to head towards. And like I said, my aesthetic, if you want to put it that way, which I have, let's say, co-opted, but in real terms, out and out stolen from Gary Holt, was that blood-spattered flying V. Like, I love that thing so much, and I've used it again and again and again and again. And I was like, right, I could do that. That's not a problem. I'll just get a flying V. I'll do my same blood splatter, motif on the scratch plate. Done, easy peasy. But then I thought, well, yeah, I could do that. But what if? Like, what if I could do something more? And the idea that I had was, rather than have a blood splatter guitar, what if I could build a guitar that actually bleeds? Like, I've never seen that before. Like, maybe Guar's probably done it, but like, it's one of those things that I've never seen before. And I thought, that sounds really cool. And then I started thinking about more things that you could do. And in the end, it all reminded me of one of my favorite movies of all time. So one of my favorite movies ever is The Exorcist from 1973. And I was thinking, wouldn't it be cool if I could sort of like meld all of these influences together into one project? And then the more I thought about it, the more I was like, yeah, that's really cool. I'm going to do that. And that's how I ended up basically where I am now. So, like I said, with the four main things that this guitar does, other than be a guitar, with the four main things it does, I'm going to break them down into their own video. So let's talk about the blood. Okay, so at that point I had it. I had a concept, I had my waypoint, I knew where I was heading. The only problem was how to get there. Now, there are really two obvious ways of doing this. The first is to have some kind of like fake blood reservoir, and then some kind of digital like hydraulic system where you would have like an Arduino or a Raspberry Pi Zero or something built in which you could program to somehow squirt the blood from the reservoir out over the guitar or to the guitar or wherever. Like you would just literally tell it how much you wanted and when, and out it came. The problem with that is that I've never used an Arduino before, and I don't really know how to program Raspberry Pis either. Like, the stuff I've been doing is super basic, using bits of pre-written code, and anything that didn't work, I kind of just fudged my way through. Like, I am not well versed enough to try and do something this specific with a programmable, like little programmable servo. The other way of doing it, which when you think about it is A, a lot easier, and B, a lot cheaper, is a completely analog circuit. And that's what I ended up doing. So I had a concept, I had a waypoint, and I had a method of doing it. Now, what I brought to this equation was previous knowledge and experience. Now, for those of you that don't know, I work in the NHS, and I have fairly extensive knowledge of a syringe driver. Now, for any of you that aren't sort of, work in any kind of medical field and are lucky enough to not know what a syringe driver is, I'll quickly explain. A syringe driver is an incredibly precise, accurate piece of modern medical equipment. What it is a small box which goes by a patient's bed, and back in the day you would have a nurse slowly squeeze medication through a syringe. Like anything that's in a large syringe or has to be administered over a long period of time, it would have to be pushed through manually. But now we can put it in a syringe driver. And what it is you fill up the syringe as you would anyway, and then you load the syringe into a tube in this sort of like small box. And what the box has is a incredibly accurate little servo motor that pushes the plunger just like your thumb would do, and pushes the plunger very, very, we're talking like micro, fractions of a millimeter, and it will do it over a prolonged period of time. You put in how much is in the syringe, and you put how long you want it to administer the medication, and it just does it over time. Because it has far more fidelity and accuracy than a human, and a human can't be expected to sit there for, an hour pumping through this syringe, fractional, like pushes of a syringe for an hour. It just can't be done. So, knowing that, I was like, I could build an analog syringe driver. And then that was it. That was the all I needed to do. Like, that was it. That was the thought I needed. And that was it. I had a direction. So I had my waypoint, and I had the direction and the process that I was going to do. It was just a case of how to get it to work. So that's what I decided to do. I decided to build an analog syringe driver. And essentially, that's exactly what I did. So what I'm going to do now is give you a quick look at the finished product. And I'll run you through the steps of the steps of the circuit. And what I'll do is I'll intercut at the end, again, some more WhatsApp footages of me just running through it and showing my mates, basically, I think I've done it. I think I've done it. I think I've built it. And then eventually, the final test, like the final field test, where everything's loaded up and ready to go. So yeah, let's get into it. Okay, so the first thing I'm going to do is highlight some of the components that I got for this build, and then very quickly show you how they all work and operate together. So, quite obviously, if you're building a syringe driver, the very first thing you need is a syringe, and that then informs the rest of the build. So what I did was I just basically built it around the syringes that we use at work. This is a Plastipack 30mm. It's a fairly large syringe, but it is for administering sort of like large quantities of medication over a long period of time. Where most NHS syringes differ to most domestic syringes is this bit at the top. Now, this is what's known as a luer lock cuff or collar around the tip of the syringe here. And what that allows you to do is allows you to screw on this luer lock adapter. Now, you can use these to attach a syringe to, say, for example, a syringe driver or an IV line or even another syringe. You can put two syringes, nose to nose, and then pass fluid between the two. So it has multiple uses, and it's very, very, very widely used syringe type. So I decided to build it around that because it was perfect for what I needed it to do. So, I mean, they're not expensive. You can pick them up on Amazon, eBay, wherever. Same as the luer lock adapters. You can get them pretty much anywhere. So I got myself a load of that. And then the other thing that I've clearly bought is this. I'm not quite sure what this is. It's not rubber. It's not like latex. It's somewhere in the middle. I mean, the lines that you have, IV lines, are very, very different. This is more like for sort of like domestic use, crafting, maybe, I don't know. You wouldn't put anything high pressure through here because it would just pop. So for what I needed, it was perfect, but I wouldn't recommend it for, I mean, it's definitely not for medical use. What I've done is I've attached the luer lock to the end with a little bit of glue, and inside there, which you won't be able to see because the glue is opaque, is I built a little, not a valve, but a little cuff to make this tube fit perfectly in here from the little membrane on a PlayStation controller. So the bit underneath the buttons, I adapted that into a little cuff, which helps the tube sit nicely inside the luer lock, because the luer lock doesn't have any kind of and it's completely smooth in the middle, so it doesn't have any kind of way of attaching this very, very thin. This is 3 millimeters in diameter. There's no way of attaching that inside properly with any kind of pressure or anything like that. So I had to make a little cuff. So yeah, that's that end. And then you can see I've cut a length of the tube all the way down here, and I've then filled it at the end with just a little bit of glue. Now, along the length of tubing, you'll see these little tiny T junctions. These I have made from little offcuts of tube, and you'll see at the end there, it's just a little offcut of tube. And then what I've done is I've cut a hole in the main artery, and then these little offshoots, these little junctions that come off, I've actually butted them up against the tube and then used clear bathroom sealant. So the stuff that you put round taps, I needed something that was clear, something that was flexible, and something that was water resistant. And clear bathroom sealant is all of those things, which was perfect. It means that I didn't have to glue it, I didn't have to use anything that was rigid or whatnot, so it's completely flexible and you can kind of manipulate it however you want. It was malleable, it's cuttable, brilliant. The only problem with bathroom sealant is that it stinks. Like, it really smells bad. It smells like really bad mouldy cheese and onion crisps. It's an awful stuff to use, awful medium, but it does the job. Inside, so here's what it looks like here. That's just with the tube and the other tube. Inside, you'll see these little white bits as well. Now, what I needed was the correct amount of pressure, and this took time. I didn't realize this. So if you attach the syringe to here, how much pressure is it going to take to get the liquid all the way down the end? Because if you leave these tubes open like this, it comes out of the first one, and it will come out the second one, and it will maybe come out the third one, but that's it. All the liquid's coming out. Like, the liquid will not go all the way down to the end of the tube. So what I did was, inside the tube, this is going to be really hard to focus, but you see that little white thing in there? What that is I had some ceramic halogen light fittings. Now, light fittings, especially halogen ones, tend to get super hot. So the wire that you attach it to the light circuit with, the light switch, is this sort of like really thick thermo shielding for the wire. Because obviously, if you're wiring up lights again, this is for my bathroom, if you're wiring up lights and the halogen lights, you don't want it to get so hot that it melts through the wire and shorts out. So it's got this really thick wire casing around it. So what I did was I got a long piece of that, say about this long, and then wrapped pliers around the wire and just ripped all the wire out. So it was just like the empty sleeve, the empty wiring sleeve. And then I cut that and inserted it into the 3mm tubing. What that does is allows me to add pressure. So by adding more pressure here, it starts dripping, like the blood will start dripping out of this tube, but then because there's constant pressure coming in from the syringe, it works its way up here. Now I can't put these little white things in each thing, because if I put them in these last two, for example, the pressure is too much and it will just pop the the main artery. So what I had to do was figure out how many of these little T-junctions needed this extra little narrowing so that the blood could make it all the way down to the end, and then how many at the end I had to leave open like this so that the blood had somewhere to escape. Because essentially, while you're pushing in blood, you're also pushing in air, and that air has to come out somewhere. So the reason that the little thinning sort of valves there aren't in the last two is just to give it some escape, just to give that pressure somewhere to get out. And now the blood goes all the way down to the last one and comes out at an even pressure along the entire tube. For the fake blood, what I went with was this. This is the classical 100% edible. Now, doing this project, I found that if you want to buy fake blood, which is something I've never done before, and obviously anything you've never done before, you want to look at the reviews, right? So I looked at the reviews, and from what I found out, all reviews of fake blood tend to be ranked by taste. Like, when it says 100% edible, and this is ranked by taste, and this is the one that scored highly on the taste rankings, people, what are you doing with it? Like, I understand that, in the course of like a theatre production or a TV production, you might need to put some in your mouth, but I mean, seriously? Like, ranked by taste? What are you doing with this? Anyway, so this is the blood I went with, mostly because it comes in, large quantities. Also, it's really cheap. Like, it's insanely cheap. The only problem with this fake blood is that it wasn't the right consistency. So if I try and use this now, I would need an insane amount of pressure, because it is quite thick, to push it all the way down to the end of the tube. So I was experimenting with different consistencies, and I eventually came up with the right consistency. And the right consistency was, for every 10 parts blood, you need 2 parts water. It didn't need to be filtered water, it could just be tap water, it didn't matter. So, say for example, you're putting 10 milliliters of fake blood. So you pull it up to here, you would also need to add 2 milliliters of water. That cuts it just enough where it's liquid enough, it doesn't look like watery. It still has the consistency and look of blood, but it's also, thin enough to pass down this super thin tube and out of these super thin holes. So that was the sort of ideal mixture I came up with after a lot of experimentation. And what I decided to do was that the side panel on the guitar, because it's going to be completely white, I didn't want, like a panel that was any other color. So the panel is white, and it's the same way I do all my other panels. I spray the back, and then the top is on there. What I did was I attached this, I need to reattach that. I didn't want to glue it too, stick it too fast, because I didn't want the paint to be removed. But on the inside of the guitar, you've got this eyedropper. So 2 milliliters of water, I think, is about like 4 or 5 drops. So you won't need to measure it out. Like, say you wanted to take it somewhere or you wanted to do something, all you would need to take is that. Everything else you would need, all the tools you would need, are in the guitar. So this pipette actually lives inside the guitar, and I'll show you where in a minute. So this was basically everything you needed to build the syringe driver. You just needed the syringe, the way of attaching it to the tubing itself, and the blood. Like, the pipette is just there so you can squeeze in the water to cut the blood, and then you don't need 2 syringes. So yeah, that's it. That's all you needed. Okay, so before I get started, there's just a couple of things that I really quickly want to point out. First is that everything you're about to see was all made with hand tools, like cheap hand tools from the pound shop. So knives, files, hacksaw blades, chisels, like all really cheap hand tools. So it's not pretty, but that leads me into my second point, which is it will be once it's been filled and sanded, which it hasn't been yet. So it might look a bit scrappy at the moment, but again, you've got to remember that everything that you see on top, no one's going to see that because of the acrylic veneer on top, like the top plate. No one's going to see any of that anyway, but even then, it's all going to be sanded, it's all going to be filled, and it's going to be painted, and it's going to look really good. I've installed the side panel on the side, so you can see like two little screw holes in here, and the pipette that I was talking about, so the syringe is loaded in, and the pipette lives down there beside the syringe in a little holder. So you never have to have like a pipette in your pocket. All you need to do is have the blood. Like, for mixing in the water and whatnot, all the tools you need are here. And obviously the little screwdriver, which again was in my last video, the little screwdriver, which is built into the strap peg. You can unscrew the strap peg, pull out the screwdriver, and that is your way in with these little screws. I made sure that all the screws I used, including the screws for the veneer top, like for the plastic acrylic top, the screws for here, the screws for the smoke machine, the screws for the flash paper, the screws for the lights, everything is all the same screw type, which are these tiny little electronic screws. So that one screwdriver can basically disassemble this entire guitar. Which leads me into another good point. The reason that this one screwdriver can disassemble this entire guitar is because of the thing that I've got with all of my builds, like whether it be the Raspberry Pis or like the PlayStation build or like anything that I've built. I love it to be modular. Like, modular is really, really cool. So, for example, if any bits of this break, or if any bits I figure something out later, or I discover something later, I'm like, oh, that would work even better, I can just swap it out. So all of this guitar is completely modular, which is why I've got that terminal block there. I can swap something out. I don't even need to desolder it. I can just literally pull it out and put it back in. Same as the screwdriver. Like, I can quickly take something out and put something back. No hassle, no fuss, no mess. Okay, and the other thing I quickly wanted to do was show you the holes that run along a trench dug on the inside of this acrylic top coat. So those little T-junctions will poke out of here, which then you can cut completely flush. Now, because you're cutting it flush and the little T-junctions themselves are white, the only thing you will see is the tiny little black dot of the hole in the middle. That is the only thing that will be visible through here. Everything else will be white. Exactly the same as what you see here. So once the guitar is filed, sanded and painted, there will be no difference between this and that, hopefully, anyway. So everything is going to be white. The reason is, on the outside, I wanted it to look completely unassuming. Like, other than those two switches down the bottom and the grill that's going to be along where the smoke comes out, you would never know that this isn't just like a standard white flying V. Like, even the screwdriver, like, that's sunk in as well. It needs to be completely unassuming. That's why the panel's flush. There's no sort of indications other than those two little screws. But even the screws are like tiny little electronic screws. You'll never see them. So, let's take off the side panel, let's take off the top front cover, and then let's show you how this thing works. Okay, so now the top cover is off, we can see inside, and I'll run you through the very, very, very simple analog circuit. It looks way more complicated than it is, but it's really, really not. And what I'm going to do is run you from sort of source to the end. Inside here is a 9-volt battery. Right, that's standard in most guitars with an active pickup. So because of that, the battery holder for a guitar is readily available. You can pick it up for about £1 on eBay, which is what I've done. I've bought a 9-volt battery holder, and that's just sitting in there. That then runs out into this terminal block. Now, the reason I've run it into a terminal block and stuffed that down behind it is that every single element of this guitar, from the headstock,
from the fire out the headstock to the lights to the syringe driver to everything, smoke machine is all going to be run off one 9-volt battery. Now that battery is not going to last very long dealing with all of this stuff, you know, together. But that said, it will run off one 9-volt battery, not at the same time. So that's why they've all got individual switches. So what I did is I put this terminal block there so I can feed everything into the terminal block. Then that terminal block can go back in here and feed all of the individual components. So it goes from the battery into the terminal block. Then this terminal block, this is where it gets, you know, maybe a little bit more complicated. But what this terminal block then does is run down this trench. Now this trench is actually quite deep because it's got 6 wires stacked on top of each other. This runs all the way down to this little micro switch here. Now this little micro switch I actually had left over from the Mega Drive build, where I built the Raspberry Pi into a little replica Mega Drive machine. This is one of the little switches I had left over for that. And what I've done is I've wired this up as a kill switch. So it's like almost like a reverse dead man switch. So it's on, it's open at the minute, and there's, you know, it can run current through it. But as soon as you do that, that's it. It just kills the entire circuit. So it goes from the power to the kill switch. From the kill switch, it comes out and then goes down here. And what it's doing is it's just done a complete U-turn down here, and it's gone into this potentiometer. So this potentiometer here is, again, it's not attached because I've got to paint it, but this potentiometer here normally would adjust speed for motors, right? So obviously you put it on here, the faster the motor goes, pull it back, slower the motor goes, right? Well, when we're dealing with what we're dealing with, it's not really speed of motors. The reason I put that in there is for torque. So obviously the more current I'm pushing through to the motor, the more pressure it will put on the syringe, which allows me to adjust the amount of pressure, because let's face it, we can try and measure out like the individual pipette of how much water to mix up with the mixture, but the blood might be a different consistency depending on where I buy it from or how much I buy. There could be any number of factors, but I didn't want it to have so much torque that it would just squirt out if it was more watery, or have too much torque if it was a lot thicker and break the pipe. So what adjusting this potentiometer does is allow me to adjust the amount of pressure depending on the consistency of the blood. So by leaving it in here, what that will do is you kind of set it and forget it. So if anything changes, you can adjust it, but for the most part, if you don't want to adjust it, it's quite happily going to sit there and you'll never have to think about it. Plus, it's underneath that plastic cover, so you won't even see it. I didn't want any switches or dials on the outside that didn't need to be there. So it goes battery, kill switch. Oh, by the way, if you press the kill switch, you can see it just cuts all the power when I push on there. So then it goes kill switch, potentiometer. Then it comes out the potentiometer, and you would assume it goes to the motor, but it doesn't. It actually goes all the way back along here and out to this switch. Now this switch is going to be mounted down the bottom like this switch. It's actually going to be in the hole next to it. The reason it's out at the minute is, again, because I've got to take it all out to paint it, and I didn't really see the point of, you know, desoldering it just to paint it, so I'll worry about that at the time. Now this is a 2-direction switch with a off in the middle. All right, so you have 1 and 2, and the reason it's like that is because you got to remember, when this thing is finished, the top is going to be on and it's never coming off. So once the top is on, it's on. If the piston rod, which is here, needs to go back, you could put your finger in the side and kind of push this back, but then you're pushing against the motor and you're going to eventually just wear out the motor if it moves at all, depending on the motor you put in there. So I was like, well, back when I did the GameCube controller and I just built a reverse polarity switch, why don't I just do that here? So what this is a reverse polarity selector switch. So currently there's no power going to the motor here. But if you rock the switch in one direction, and then if you rock the switch in the other direction, See? So you never have to open up the guitar to push the piston rod back. What you can do is just once your blood display is done, you just go, right, okay, set it up, take the syringe out, load the piston rod, and that's it. You're good to go again. So it eliminates, you know what I mean, any more work than was needed. So then obviously from that switch, depending on, you know, where it goes, so that switch then comes back and ends at this little motor. These motors cost a couple of quid. They're not expensive at all. And they're really good reduction motors. What I've done is I've put it in and put this sort of shrink tubing around it. And then this little gear system here, again, cost a couple of quid on eBay. Not really expensive. And then what I've done is I've cut a trench out, obviously, for the piston rod. And the piston rod comes out, you know, into this sort of large recess here. So you've pretty much figured out so far how this thing works. All right, but let me show you it working together. Okay, so I've put the tubing in. Just again, the top cover's not on for the minute, but it's just an example of how this goes once it's all together. Now, you've loaded up your syringe. Your syringe is ready to go. You've taken out your strap peg. You've opened up your plate on the side, and then you're now going to load your syringe. So what you do is you put it in to the lure lock system here, which obviously you would use 2 hands for. So there you go. So that's now attached to the lure lock. You then push in the syringe and the side. Now remember, you're never ever ever using the you're never putting your fingers in the top. You can do all of this via the side. You've got so much finger room in there. Okay? The tail of the syringe is obviously pulled down to as much as you want, but these syringes have a kind of like cross section that's an X cross section, and that micro switch sits really nice inside that cross section and sits underneath that slide. It's not actually touching the syringe whatsoever. It's just tucked below it. You can probably see down there. It's just tucked underneath it. So now your syringe is in, your syringe is attached to the lure lock, which then goes around. I mean, this never comes out as well. Once the tubing's in there, that never comes out. All you do is just put the syringe in. So you've screwed back on your side panel. Your pipette is in there because you've already mixed it up. You don't need that anymore. Time to go, right? So what we're going to do is we're going to set it into the forward position. Forward position. And now you can see that is very, I mean, obviously you can set from the potentiometer how much pressure you want. Because this is empty, it's pushing really, really fast. But you just set it to, you know, whatever kind of speed you need. That then is closing the syringe, which is then pushing the blood up and around and out. And then, once it gets to that little micro switch, click. That little micro switch is touched by the little thumb pad, and then that kills the potentiometer. So why do that? Well, what I didn't want to do was ruin the syringe, ruin the gears, ruin the piston, or blow out the little motor by it constantly having power given to it. That's why I put the little kill switch in there, so you can kind of just turn it on, let the blood flow, and kind of forget about it. Once you're ready to reload it, you set it back into your off position, remove the syringe, which again you would all do from here. You never put your fingers in the top. So you remove your syringe, and then you can set your switch up the top. Say, okay, I want to load it back. Load it back. Good to go. And then you're ready to reload it and do it again. So yeah, that's basically how it works. It's really simple. Like, I know it looks complicated, but it's really not. It's super, super, super simple. And the hardest part of this entire project was, how much blood do I need? How thick does it need to be? And then constantly adjusting this potentiometer so it's just right for the consistency that you want. But yeah, I mean, that is the circuit in a nutshell. And what I'm going to do is basically show you the process of me trying to figure out how it worked, and trying to figure out how much, with the final field test being, I think 2 weeks ago, I'm not quite sure, but the final field test was a while back, and man, it looked good. Okay, this is literally the take one. This is literally my first time trying. This is my first time trying the hydraulic system inside to pump blood, and I'm just using a little bit of water, just basic filtered water. And look, check it out. We have blood coming out of the irrigation tunnel. All I'm doing is just gently squeezing in this 30 ml. But as you can see, if I do that, there it goes. Blood. Okay, so I think I've found the perfect mixture. If you mix 10 milliliters of blood with 2 milliliters, maybe 2.5 milliliters of water, you can push it through and check it out. Hang on. Now what I've done is I've actually made the holes at the front thinner by putting in small little pieces of wire, the heat resistant coating on the wire. I pulled the wire out of the middle and taken the heat resistant plastic and put that inside the tubing, where the last ones don't have it, so you don't build up a massive amount of pressure, so it pops the lure lock. But as you can see, I'm just putting a tiny amount of pressure on that. If I squeeze it a bit more, like, it turns into Evil Dead. Okay, so let's squeeze past. Hopefully this works. Like I say, we've got a little bit of leakage down here already, so I think it's going to work. Right, so what I'm going to do is just apply a little bit of pressure where the motor is, because I have to put in a little pad to push it down onto the piston, but I can't do that until I've painted it, otherwise there'll be a big hole in the paint. So I'm just going to push down here, simulate that, and slowly turn up the potentiometer. Oh my god, look at that. How much more pressure do I need? Here it goes. Maybe that's too much, I don't know. Oh no, there it goes, there's some more. Is it climbing? It is climbing. Oh my god, look at that. Let's put a little bit more pressure on that. Oh, that looks so good. Okay, it looks like we've got a little bit of a, oh, that's the thing slipping. Come on. Oh, that looks so good, right. Yes, it's coming out the back end. Okay, good. So I need quite a lot of pressure on that motor then. Is it climbing anymore? It is climbing more. I can see it coming along this thing. There's also a little leak in the pipe there, but that's fine. I can sort that out. Oh, okay. Maybe that's a bit too much pressure. Ease it off a little bit. So I think we need maybe the mixture's right. Maybe. I don't know. I don't know if I need to add more water to the mixture. I mean, that's at full torque now. Oh, that looks so good. Alright. Let's ease off the potentiometer and add slightly less pressure. I'm absolutely covered in blood right now. It's still going. It's still very, very... What I'm doing is just adjusting the potentiometer with my left finger. And all it's doing is just adding a little bit here and a little bit there. Oh my god, that looks so good. Alright, what I'm going to do is I'm going to call that there. Let's just quickly switch off the potentiometer, set it back to its neutral position. Okay. Right, well, let me just run around here. Well, I mean, yeah, I got covered in it, but look at that. That's exactly what I was going for. And it's just rolling down here. Like, fair enough, some of it got in there. So I've got to maybe put a shield around the thing. But this is why I do these experiments, just so I can see how it's going to look before I actually do it. It needs a little bit more water, if I'm honest, just a little bit more. But I do love the trails. But the trails aren't going to be there on the finished product. They're going to look like that because it's going to be clear. So it's not going to look like that. It's going to look bright white, but they're going to kind of blob up like that and then turn into streaks like that, almost like it was glass. But that looks pretty much how I wanted it to look. That's so cool. I mean, that's where my hand was, but that's so cool. So I'm going to need either more pressure or, yikes, or less water, or more water, less pressure. And I'm going to need some kind of, maybe I don't need to put a pad on the underside of the scratch plate. Maybe I can just put like some of the thermo shrinking tube over the top. I don't know, but that's looking pretty nice so far. And that's literally with just a 9-volt battery, a syringe I got from work, and some tubing for like £1, I think, £2 that I ordered off the internet. So yeah, I know there's also a small hole in the tube, which I've got to fix right there, clearly. But still, I mean, hell yeah.
Okay, that's 1 down, 3 to go. From the conceptual start of this, you know, like, wouldn't it be cool if I could make a guitar that bleeds, all the way through to the physical manifestation of where this guitar is now, I am so happy with the way it's turned out. There were a lot of small details that I needed to kind of adjust and get right. So, you know, how thick should the blood be? How big should the holes be? How much pressure? How much torque? Lots of things to consider. But the actual design, like the actual sort of like design of what I wanted to do, kind of just worked out. Like, it was really, really cool. The reason that that's so surprising is that I had to get out of my comfort zone of, if I don't know how to do something, just ask the internet. There is no diagram or help for this on the internet because, as far as I'm aware, no one's done anything like this. Like, I was kind of just winging it. Like, just get the tube, figure out how to make the TJ, all that kind of stuff. I can't just ask because it's too specific for this job, that I just needed to figure it out. But the fact that this works as well as it does is a miracle. So yeah, I'm super happy with the way that this has come out, and I cannot wait. I am so looking forward to getting this thing filled and sanded and then primed and glossed and painted, and the acrylic, you know, top sheet to have that nice Arctic white paint job on the underside, because I really want to see what it looks like when that blood is running against that brilliant white background. It's going to look so cool. So yeah, I'm really looking forward to that. But for the meantime, that's the end of this video. The blood is working. The next video is probably going to be... See, I wanted to do something that was either make or break. So of all the 4 elements, the one thing that could make or break this thing is the lights, which really doesn't seem like it would be, but it is, because when it looks right, it looks awesome. But when it looks wrong, and if you get it wrong, it can completely ruin the whole aesthetic. Yeah, let's, in the next video, let's look at the lights, and hopefully, it turns out as well as this did, because, man, I am really happy with the way this is at the minute. All right, cool. Peace.